If you are trying to develop a walking robot that has a length of 2 millimeters, it goes without saying that there is not any room for a battery. This is why Georgia Tech resorted to vibrations for its latest micro-bristle-bots. Someday, these micro-bristle-bots will be capable of moving within the human body. The micro-bristle-bots are 3D printed using polymer resin via a process that is known as two-photon polymerization lithography. Each one of the robots has either 6 or 4 springy legs which are more like bristles, thus giving it its peculiar name. Furthermore, a piezoelectric actuator created from lead zirconate titanate is glued on the back of each bot. Vibrations are applied to the micro-bristle-bots using a shake table or an external ultrasound, sonar source or using a tiny acoustic speaker. These vibrations can cause the angled legs to move up and down, thus making the robot move forward. The actuator is also capable of creating vibrations when it is subjected to an electric current, but currently that current has to be provided via hardwired source. It might become possible, later on, to wirelessly activate the actuator by making use of electrical fields. The speed at which the micro-bristle-bots move is determined by the amplitude of the vibrations. Furthermore, tweaking their legs' size, diameter, and geometry, the bots can be designed so that they respond to a different frequency of vibration. Thus, by linking two uniquely designed bots, it will be possible to steer the duo by changing the frequency and amplitude of the vibrations. As of right now, hundreds of such devices have been created, and the research team is looking for ways to scale up the manufacturing process to create thousands of these micro-bristle-bots at once. The applications of these bots include movement of materials within small spaces or even treating injuries within the body. A paper on the research that is being led by Assistant Professor Azad Ansra has been published in the Journal of Micromechanics and Microengineering.